Section 3.5 Derivatives of Trigonometric Functions. Let's start by taking the derivative of the sine function. It turns out that the derivative of the sine function is equal to the cosine function. How do we show this? First of all, we need to recall a few things. First, the sum identity for sine of a plus b, and it's equal to sine of a times the cosine of b plus, this time, cosine of a times the sine of b. Next is that, recall that we derived the limit of sine of t over t as t approaches 0 in Chapter 2, and it's equal to 1. Also, the limit of cosine t minus 1 all over t as t approaches 0 is equal to 0. So let's begin by defining taking the definition of derivative. F prime of x is equal to the limit of f of x plus h minus f of x all over h, taking the limit as h approaches 0. Okay, we will begin by first of all, let's take our function f of x, and it's equal to sine of x. This is the function that we want to take its derivative. Then, what is f of x plus h? Well, replace the argument of sine of x by x plus h. So this is just sine of x plus h. Now we replace all of these in the difference quotient, so this is now equal to the limit of sine of x plus h minus sine of x, whole thing divided by h, taking the limit as h approaches 0. Okay, so how do we write sine of x plus h? We will use the first bullet. So continuing on here, we're taking the limit of, okay, what do we have? It's the sine of x times the cosine of h plus cosine of x times the sine of h minus, okay, our f of x is sine of x, so we just copy that, minus sine of x. Everything will be divided by h, and we let h approach 0. What we will do now is to rewrite again and regroup a few things. First of all, I will take this middle term and put it in the front, and then combine these two terms and put it on the right. So I'll have the cosine of x times the sine of h, whole thing divided by h. Okay, so far what we've got is I took the middle term, okay, and then we add, this time it's the sine of x times the cosine of h, that's the first term, minus sine of x, that's the third term on the numerator of the quotient, whole thing divided by h. Okay, now remember, what we're taking the limit is with respect to h as h approaches 0, which means cosine of x is a constant term. Here, sine of x is also a constant term. Okay, so now if we keep going, we're taking the limit of, okay, I will write cosine of x times, just to make it obvious, sine of h over h, okay, plus I will pull out on this second quotient, I'll pull out the common factor sine of x. And what is left then, if we pull out the common factor sine of x, it'll be cosine of h minus 1, whole thing is divided by h, we take the limit as h approaches 0. Do you see now why we have to use the second and the third bullet? Because when we take the limit of a constant times this expression, this whole thing, sine of h over h, goes to 1. The limit is equal to 1. And this term, cosine of h minus 1 over h, if we take the limit as h approaches 0 using the third bullet right here, the limit is 0. So what we've got so far would now be cosine of x times 1 plus the sine of x times 0, and therefore the limit of this whole quotient expression is equal to cosine x. Therefore the derivative of sine x, of course with respect to x, is equal to cosine x. Done. Now if we take the derivative of cosine x, now this time we will use the sum identity for cosine of a plus b, and it's equal to the cosine of a times the cosine of b, and instead of having a plus sign we have the opposite sign here, so it's plus here and that's minus here, so it's minus sine a times sine b. So the same thing as we did in taking the derivative of the sine x, we will take f prime of x by definition equal to the limit of f of x plus h minus f of x, whole thing divided by h. Take the limit as h approaches 0. So here our function that we will differentiate is the cosine of x. Therefore f of x plus h is equal to the cosine of x plus h. So we will use the sum identity for cosine of a plus b in the difference quotient. So now what we've got will be the limit of cosine of x plus h minus the cosine of x. There's your f of x plus h minus f of x. Whole thing is divided by h as h approaches 0. So let's go ahead and substitute, and what we will get will be the limit of the cosine of x times the cosine of h minus sine of x times sine of h minus cosine of x. Everything is divided by h, taking the limit as h approaches 0. Like we did previously, what we'll do now is regroup a few things. So what we'll regroup would be, first let's take the middle term and put it in the front. So what we've got is the limit of minus sine x times sine of h over h, okay, plus cosine x times cosine h minus cosine of x, whole thing divided by h. Alright, let's see what's happening. We're taking now the limit of, again I will rewrite the first term in this way, minus sine of x times sine of h all over h plus, what is the common factor here? It's cosine of x. So plus cosine of x, okay, pull it out, and what's left is the cosine of h minus 1 divided by h, taking the limit as h approaches 0. Okay, And what is the limit of sine of h over h? As h approaches 0, the limit is 1. Here, the limit goes to 0. So what we have is the negative sine of x times 1 plus the cosine of x times 0, and of course that's equal to negative sine of x. And there we have shown that the derivative of cosine function with respect to x is the negative of sine of x. Graphically, what would that mean? Let's look at this slide, and here let's examine, of course, the slopes of the lines tangent to the curve of cosine of x. And where there are horizontal slopes, or zero slopes for horizontal tangent lines, that would mean that the derivative function would be crossing the x-axis. So how many points here where it will cross the x-axis? It will depend on the original function where we would find horizontal tangents. So we have 1, 2, and 3. Correspondingly, it is at minus pi, 0, and pi. So then we mark the derivative function by the x-intercepts at minus pi, 0, and pi. Okay, so from here we see that the slopes of the lines tangent to the curve are negative, therefore the function of the derivative would be negative. Okay, and then from 0 to pi, the slopes of the lines tangent to the curve are all positive. That's why the derivative function is above the x-axis. And then from 0 to pi, it will be negative slopes, so the curve of the derivative function would be negative below the x-axis, and so on and so forth. Okay. Because recall that the graph of sine x looks like this. Somewhere like that. Okay, and on the other side it goes this way. Okay. And so we see that this is the graph of y equals sine of x. And of course, if we reflect it about the x-axis, then we'll take the negative of sine of x and we get this curve. So graphically, we have shown that the derivative of cosine of x is equal to the negative of sine of x. Here are other derivatives of other trigonometric functions, and we will just show a few of the derivatives here. Like, say, if we take the derivative of tangent of x, and how do we know that it's equal to cosine of x? Okay, let's go ahead. This time, what we will use are just the differentiation rules. So if I take the derivative, okay, of tangent of x, whole thing with respect to x, what it is I am really taking the derivative of the quotient. By definition of sine, it's equal to, by definition of tangent of x, it's equal to sine over cosine, sine x over cosine x. So if we differentiate this, we're actually differentiating a quotient, so we will use the quotient rule. It's equal to, first let's go ahead and square the bottom, cosine squared x. And the top would be the derivative of the first, the top, which is cosine x, times the bottom, which is cosine x there, okay, minus, this time we take the derivative of the bottom, which is negative sine x, multiplied by the function on the top, times sine x. And what do we have on the numerator? That's equal to cosine squared x. Negative and another negative would be plus sine squared x. Now, what is on the numerator? What is this? It's the fundamental identity of the unit circle. That's why this whole, the sum of squares of cosine square x plus sine square x is equal to 1, and whole thing divided by cosine squared x. And what is the reciprocal of cosine? It's equal to secant squared x. Therefore, the derivative of tangent is equal to secant squared x. So what do you think? How do we differentiate the derivative, or how do we show the derivative of secant x equal to secant x times tangent x? Again, use the quotient rule. And same thing with this other two functions here. Use the quotient rule again, which means we will take the derivative of cosine over sine. Here we're taking the derivative of 1 over sine x. I'll let you do the rest of showing the derivatives of these trigonometric functions. So what you can do right now is pause the video and then try out how you can take the derivative of cotangent of x and say the derivative of cosecant of x. For our exercises, I got these problems from page 139 of your textbook. Let's try number 1. What is the derivative of y equal to negative 10x plus 3 cosine of x? Number 1, y prime is just equal to negative 10 for the derivative of minus 10x plus 3 times, what is the derivative of cosine? It's negative sine of x. So if we rewrite this now, it'll be minus 10 minus 3 sine of x. How about number 2? For number 2, y prime would be equal to, first of all, let's go ahead and see if we can rewrite this as 3 times x to the negative 1 plus 5 times sine of x. And then we use power rule, bring down negative 1, we'll have y prime would be equal to minus 3 times x to the negative 2 plus 5 times, what is the derivative of sine x? It's equal to cosine of x. So that's equal to negative 3 whole thing divided by x squared plus 5 times the cosine of x. How about number 3? If we do number 3, what we're looking at is a product of x squared times cosine x. So to take the derivative, y prime, first, let's take the derivative of the first term, which is 2x, multiplied by cosine x. Then this time you add the product of x squared times the derivative of cosine, which is minus sine of x. So that will be equal to 2x times cosine x minus x squared times sine of x. Okay. Now in number 4, that will be equal to, alright, so first of all, let's rewrite this as x to the power 1/2 times secant of x plus 3. So y prime therefore would be equal to, first let's take the derivative of x to the 1/2, which is 1/2. X to the 1/2 minus 1 would be negative 1/2 times secant of x. Okay, so we're using the product rule on the first term. Okay, plus x to the 1/2 times the derivative of secant, which is secant x times tangent x. And of course, the derivative of 3 is 0. So I'm just going to go ahead and write plus 0 here. Okay, just to show you that that's a derivative of the constant 3. Okay, and just the rest would just be a few arithmetic. So we'll have, okay, it's equal to 1 over 2 times the square root of x secant x plus the square root of x secant x times tangent of x. Okay? And you can, if you want to further simplify, you can pull out the secant of x here. So that's equal to secant of x times, the whole thing would be 1 over 2 square root of x plus square root of x times the tangent of x. Okay? Let's work on this problem. What is the derivative of y equal to 4 over cosine x plus 1 over tangent x? There are different ways of approaching this problem. You can either use the quotient rule for these two terms or rewrite them as equal to, well, this is also 4 over cosine x is the same as 4 times secant of x. And then if we take 1 over tangent, that's equal to cotangent of x. And then that's your y. So now y prime therefore is equal to 4 times the derivative of secant of x, which is secant x times tangent of x, minus cosecant squared x. Okay?